Morning everybody, and once again welcome back to the channel. In this particular video we are going to take a look at how to use the Yarn Capacity Scheduler on Amazon EMR for multi-tenant workloads. So let me ask you this question before we do a hands-on lab, right? So in a typical EMR cluster, a lot of hundreds of jobs are going to be running. Some jobs are going to be processing hundreds of gigabytes of data, right? And it's natural that these jobs will require more resources. Now the challenge becomes is okay, if there are a certain burst of these jobs coming in which will take most of the cluster resources, other jobs are not going to have the resources they need. So how to allocate the resource fairly, right? So we learn how you can configure your EMR cluster, set up queues such as high priority, low priority, or based on department, and allocate resources to each particular queue. And then when you submit a job, the resources are allocated on a fair basis. So again, before we go hands-on lab, I do want to just cover a little bit of theory. I'm not going to cover everything, but I'll cover FIFO and FAIR over here. So let's take a look at the FIFO, right? So for example, first in, first served, right? Jobs are scheduled one by one in a submission order. So for example, let's say you have a queue called SLA high, right? And which has 10 GB of resources. 10 GB is a number that is taken just for explanation purposes. Job 1 needs 5 GB, job 2 needs 10 GB, job 3 needs 8 GB. So in this case, what would happen is, job 1 would consume 5 GB, second job does not have resources, so it has to wait, right? So again, the resources are allocated based on first in, first out, right, basically. So that's the FIFO ordering. Again, here is the configuration that you can use. Yarn.scheduler.capacity.root, this is the queue name usually. .ordering policy, you can set that to FIFO. Now what is fair? Now let me take an example of that. All active jobs share resources equally inside the queue. For example, if you have 3 jobs, 5, 10 and 8, this is what you have requested, right? And this queue has about 10 GB of memory. Yarn gives around 3.3 GB to each instead of letting the first job take all of it. So it's the resources are allocated on a fair basis, right? So I hope you got an idea. Now again, there is user first ordering as well, and there is priority utilization as well. You can read more here. But ideally, in a typical batch scenario, FIFO is usually preferred for batch pipelines. When would you use a FAIR? So multi-user unpredictable workloads, that's when you can use probably FAIR. And again, I would say read more about the user first and the priority utilization. Now, okay, this gives a good idea. Now, how do we even, let's do a lab, right? Because unless we do a lab, we are not going to know how to create a cluster with the settings, etc. So now it's time for a lab where I'm going to spin up an EMR cluster with this setting, and I'm going to walk you over this step by step. Alright, so we're going to do this lab, and in my opinion, I think the best way to learn anything, any new concept is to try out, okay? So, you can take a look at it, how many times I've tried yesterday. So, alright. So let's actually go over here on one of the cluster that I had from the past. Click here and click on clone, and then I'll walk you over the setting. Again, we just need Hadoop and Spark. We don't need anything else, so that's good. We're going to use an M5 extra large. This should give me about 16 GB of memory and 4 cores, right? If you need more cores, simply go to MX2X large, 4X large, 8X large, or choose a different instance. I'm going to choose 1 core node again with the same configuration. Okay. The rest everything I'll keep it to default. Over here, as you can see. Now here, this is where you will paste the settings, right? So software settings, right? So let's now go to my IntelliJ and take a look at the settings. So let me zoom in because I know people are going to watch from phone as well. Alright, yarn scheduler.capacity.root.queues. So these are the 2 queues that I'm defining. SLA high and SLA medium. Again, these are the 2 queues. Again, the total has to be always be 100, okay? Now I'm saying that, hey, out of the total cluster, I want to allocate 70% to the high queue, right? So 70% of resources are going to be allocated to this, and then the remaining 30% is allocated to SLA medium, okay? You can also define a min. So what I'm saying is minimum this queue should have 20%, and the maximum is 70, right? And same here, right? A minimum over here is 15 and the maximum is 30. So in a way, simple, man. Let's make it simple, right? High can have maximum of 70% of the resources, and medium can have maximum of 30% of resources. So now let's copy this, okay? Let's go to software settings and paste this one here, okay? Just double checking the settings. Okay. And then I'm just going to click on clone cluster. Now, ideally, this takes about like 5 to 10 minutes roughly to provision the cluster, of course. So let me go to clusters, and here you can see my cluster is in a starting state. So let me wait here because this could take a bit while, right? So once my cluster is probably in the waiting state, let me resume the video and then move forward. Okay. So also just a quick note, if in case the setting that you are trying is not applied, you could SSH or SSM into the cluster and then run a bootstrap script. I will show you that as well in case if that doesn't work. So I'm gonna SSH into my EMR cluster. As you can see, I've done that. Okay, and now here I have a bootstrap script, as you can see over here. Let me zoom out. So again, this will get the total memory and the code that the cluster has, as you can see, right? And then after that, it will update the yarn site.xml file, and then it will also do CapacityScheduler.xml. So these are the two files that are modified. Again, same thing, right? We are just defining the same config through an XML. So SLA medium, SLA high, these are the two queues that I need. So let me copy this. I am into my master node, and I'm just going to run this script, and this will create the two queues that we were talking about. Okay. So now that I've ran that script over here, I should be able to do yarn queue list all, and I should be able to see my two queues, and you can see SLA medium and SLA high. I can see my two queues, 30% and 70% have been allocated to that, right? So just in case, I'll attach this script in case if you wanna try, it doesn't work and you wanna try this, feel free to try that as well. So now that's done. Now what we can do is I have a let's see where it is, test.shell. So yeah, this is gonna submit a bunch of Spark job to the queue. As you can see, this is gonna submit to the high queue. This is gonna submit probably to a medium queue, right? So we're submitting a simple Spark job. These are just a sample Spark job which will calculate the value of pi, right? So what I'll do is now I'll create a shell file called test.shell, and then I will copy this code there. Okay, and then I'm gonna say chmod plus x /test.shell. So I gave the permission. Now before I run, right? So here is my EMR primary node public DNS. So I'm gonna open up a new browser. Okay, and if I go to that :8088 is, I believe, where the resource manager should be there, as you can see. And now we're gonna take a look at the scheduler. So let's go to scheduler. And here you can see, right, root SLA.medium, root SLA.high. I can see my two queues. Now when I submit the job, you will also be able to see these percentages, right? You should be able to see the job in the probably the running or the accepted state, and you can see all the statuses, right? So let's submit the job /test.shell. So I've submitted some jobs at this point. Okay. Here you can see these jobs are being submitted. Now if I go to probably accepted stage, I don't think it's submitted yet, so I just have to wait a little bit. So as you can see, the jobs are being submitted at this point. Okay, so the jobs have been submitted now at this particular point. So if I go to probably accepted, or if I just go to running, maybe, let's see if I can see those jobs. And you can see these jobs are currently, the resources are being allocated. I just tailed into the logs right now. So let's be a little patient, and once probably they're accepted, you can see that in the resource manager. Let's go to running. So here you can see I have one job that's currently running, and it's the high one, right? So that's being ran. So at least we are able to see, and here you can see SLA high, right? You can see 47% is used in that, right? So again, hopefully just wanted to show you, right? And here you can also see the user limit resources. Again, how much is used and how much is the user has the limit, right? So you can't go beyond this one. Of course, I have a very small cluster, for testing and playing purposes. But what I really want to do is I want to show you how the overall process looks like, right? So yeah, and then if you go to the application section, here you can see all the applications that are probably running or accepted, etc. So here you can see currently this is only the one that's running. Let's see, I can see the queue. Yeah, that's a high priority queue, right? So as you can see, that's currently being run. Of course, once it's done, again, more and more jobs will be now submitted. As you can see, this is the job, that's the resource that it got allocated. So yeah, I would say that's all I have for the video. I hope you enjoyed. I couldn't find any of our video or resources like this, so I hope this will help a new engineer who is trying to figure things out. So I think this is a very good resources. Now that being said, on the Medium, I also have two good blogs that I read, from which I was trying to understand things better, right? So I would leave them as well in the description, so please check that out. And if you have any other questions, let me know. Until then, keep smiling, keep programming, and I'll see you in the next video.